right, up next, we got Enrique Lopez Manas. And he's going to be talking about Kotlin Native.
Hello, everybody. Well, thanks, everybody, for coming. It's my first time in Canada. I'm very excited to be here talking about Kotlin Native with you. And just very shortly about me, I'm a freelance developer. I'm originally from Spain. I was born in Madrid. I live in Germany, since a number of years. Also, I work remotely, so I travel quite a lot. I just basically bring my office, is this thing over here, into another country, go to a coffee, and code a bit. I'm part of the Google Developer Expert Crew, and this is my Twitter handle. I'll post later the slides. If you have any question at any time, please feel free to approach me there, and I'll be more than happy to answer. Now that you know something about me, I want to know something about you. Who has experience here with Kotlin in Android, since this is an Android conference? OK. In iOS, has anybody tried Kotlin Native for iOS? OK. Backend? Somebody in? OK. So I hope you can learn a bit today about how to move forward on multi-platform development. So let's gonna move first into what's the motivation for doing multi-platform development. The first idea that came into our mind are obviously the cost. If we are developing several applications, an application for several platforms, and we can cut on developers or develop the same code once instead of several times, that's a very obvious save in cost. I think it's not the first argument. In general, in software engineer, I think you have a better output if you direct your arguments toward quality. Having a single code base or some part of code that is being reused, it, as an obvious consequence, increase the quality of your software. You all know in GitHub or in those continuous integration environments, you have the coverage of tests. Imagine if you could have the same code base that is is used in several projects. It's easier to cover with tests. In general, I think one of the main things you should try to do in software development is write as less code as possible and be very lazy, because obviously you will have less code to maintain, and you will have less bugs and less problems. Now, another of the things that is a very strong argument for multi-platform development is to share the same code with the company. You probably have found in many scenarios a company that develops something called a mobile library or mobile kit or something similar. Because in many companies, you have a core functionality for different apps. You maybe have the same backend. You save the stored information in some way. And you have this library that you keep reusing about between different applications. And of course, you could organize the code as organize your team as in feature teams and not just organize them per platform. I think that's a very interesting approach. You could have a team that is coding a feature, is getting expertise in this feature, and is not being separated by platforms. There are some papers, and if you Google about how to organize a feature team, it has some advantages. I think it's good to have different options. There is obviously no silver bullet in software. You have different possibilities, different paradigms, and you just need to choose the one that fits better for your team, your culture, your situation. Now, before we started with, or since I've been developing software, I think there has been always a few paradigms that were used for multi-mobile development. We have on one hand the platform proprietary software, Xcode for iOS, Java or Kotlin to develop applications for Android. Basically since forever, there was this paradigm of having a hybrid HTML frameworks and JavaScript frameworks, such as PhoneGap, Cordova, these sort of technologies that were able to code once, develop and deploy to different applications. The main counter-argument against those frameworks is that they generally were not that efficient, because HTML is essentially a markup language, not a development language. One could argue it's not a language. And you basically cannot talk with the hardware as you can if you're developing the application with the native solution. So I think they make sense in some context. I think in enterprise software is a case where they can be easily applied in these banking applications that is basically a form. It doesn't need to be to look good. It doesn't need to have any nice UI. You just need to put some numbers and send them through the network. In that case, you could consider them. Then we have also the cross-platform native solutions. You probably heard of Xamarin. Does anybody has here experience with Xamarin? OK. So Xamarin, React Native, I think React Native maybe now is more of a thing. Xamarin had this thing that I think the licensing and the opening philosophy that it has was preventing them from being widely adopted. Now, I don't know if the license is now free or not. At some point, it was significant, like a few $1,000s, which I think it can prevent a startup from adopting them. So, well, those are the word approaches that we're taking until now. Now, if we are thinking about Kotlin, why should we use Kotlin Native instead of Xamarin or HTML or PhoneGap or what is bringing Kotlin into the table? Well, Kotlin is a modern language, whatever that means. But if you put that in perspective with Java, the first version was released in 1995. Think about that. It's 23 years ago. That's forever in computer engineering. They also had this release cycle that is, they don't release that often. Sometimes you have problems between versions. You have these minor versions that last only for a few months, the major versions that are going to be adopted for a longer time. And the most interesting thing is that Oracle right now has more lawyers than developers. So it's a copyright company. It's not a software company anymore. And well, Kotlin, it doesn't follow that paradigm. It's actually developed, by JetBrains, this top-notch company that make a lot of tooling, and they're very good at what they're doing. It can interoperate with other platforms. So if you are developing for Java, it's out of the box. You can compile from Kotlin into Java. You can transpile into JavaScript as well. And now with Kotlin Native, you can talk with different platforms. It's something that they do very well. And particularly, IntelliJ has done a lot of effort in tooling. If you develop for Android, you have this converter from Java into Kotlin that works relatively efficient for the job they're doing. Then, of course, the community support, which might be more of marketing work rather than the technical part, but it's equally important. You can't have a successful language unless you have a community that is supporting it. Because you need to develop libraries, you need to support them, you need to have the open source ecosystem around it. And Kotlin actually has it. You have a few reports, like the increase in popularity in GitHub. There is this Tivoli index from programming languages, where they're also increasing every year a lot. And they definitely have the community support there. All the top tooling that they have from JetBrains. Actually, one thing that is fun is that this is how good JetBrains it is. If you develop for iOS with Xcode, you could not refactor Swift code until recently. Swift code is done by Apple. Xcode is done by Apple. And app code done by JetBrains could refactor Swift. So this is the kind of tooling they do. And one important thing as well is that this is sharing your code through Kotlin Native is optional. Adopting Kotlin Native doesn't mean, oh, I'm going to stop doing the things I did before, and I have to jump 100% into Kotlin Native. You can do that progressively, and you can do that only for for different parts of your application, which allows you to try it progressively. You don't need to jump. You don't need to take any risky decision. It's not a life or death commitment. To show a bit the current situation of Kotlin here. This year was exciting. In the first, until now, we moved from up to the version 0.093. That's the current version that was released at the previous Kotlin Conf. It was, I think, for some people, a little bit of a disappointment because we were expecting a stable version, including a bunch of things, but still, it's not that bad. The version 0.93 includes the IDE tooling for Kotlin Native and the coroutines in Kotlin Native, with some limitations. Who knows coroutines here and have tried them? OK. Coroutines are single-threaded in Kotlin Native, which might be something not so convenient. It's something that could change and will eventually change in the future, because it's one of the biggest demands. But as it is right now, it's still single-threaded, which could be a limitation in some environments. Now, before Kotlin Native, the purpose from JetBrains was to develop something called Kotlin Multiplatform or Kotlin Anywhere. You could develop on your server, maybe your DTOs or your objects. You could share them on your Android application and maybe transcompile them into the browser. And stop developing a little bit more. So essentially, what Kotlin Native and Kotlin Multiplatform does now is we have a common module that defines the common functionality that gets compiled into the JVM and into the native module. And this is a mobile conference, so GS I don't know if mobile developers do JS, but well, it's also part of the deal. You could also compile into JS. Now, this doesn't mean that you do the entire application in Kotlin and you need to deploy all the modules. Essentially, if you're developing, for example, for iOS, you would make your set of functionality. This could be compiled into an iOS framework that later on goes into your application and combines with the rest of iOS stuff you're developing. And same for Android. You would compile into the JVM. This would be used in your Android application, and you could keep doing your Android things and your Android stuff on parallel. So this goes into another point. Kotlin Native, the focus it should have is about sharing an architecture and not the UI. There is an explanation for that. Google does not care too much about iOS UI, and Apple does not care too much about Google UI. And I will go with Flutter later. Essentially, there are different paradigms of usage. Sometimes you don't have the same interaction with them. And it's actually a mess if you really try to combine some controllers and trying to write them once and combine them several times. So Kotlin Native is very apt for sharing things that are common, because if you think about a few things in a mobile app, essentially under the interface, everything is the same. You have threads. You have storage. You have some networking. All those things are common, and they perform it essentially the same way. An iOS application will call a service, get a JSON file, get the data, do whatever you want with the data, maybe store it, maybe answer back to the backend, etc. So now a few more technical details about Kotlin Native. It uses the LLVM. If you don't know what it is, it's a collection of compilers that was done by Chris Latner, I think is the name, who's also the designer of Swift, the language. He was working at Apple, at Tesla for 2 weeks, and now he's working at Google Brain. And with this, the version 5.0, you can actually target multiple platforms. It provides runtime guarantees, such as exceptions and memory management. You can interoperate with C and ObjectiveC, and obviously Swift through a library called libclang. Not with C++. I heard somewhere that C++ cannot talk with C++. So maybe that's why they decide that Kotlin cannot talk with C++ either. And you also have a few platform libraries, such as POSIX, Apple frameworks, Win32, etc. So you can create your application, compile it in Windows, and have a very beautiful .exe file that can execute and proceed as you want. The procedure is pretty simple. Generally, you start with your own .kt file with your Kotlin source code. This file will go into the Kotlin compiler, and through an intermediate representation, will go later to the LLVM, and it will get converted into the platform binary of the platform that you use. It could be Android, it could be iOS, it could be Windows, it could be Macintosh, it could be Linux. The compiler itself, it shares the front end with Kotlin JVM and Kotlin JS. The compiler itself has been written in Java and Kotlin, and produces the bitcode through the API from LLVM. Now, maybe a bit about the memory management. I think those things are, it's important to get it at some point. When you're starting, I don't think it's very productive to get so overwhelmed with all the details, because this is something that comes naturally when you're developing. The Kotlin Native uses an ARC. You probably know it from platforms such as iOS. Java uses something similar with a cycle collector. That means in every cycle, the ARC is running. It tries to check which reference can be removed, which object is not being referenced anymore, with some internal politic, etc. When we are working with pure Kotlin, we don't have to worry about memory management as much as you don't have to worry about memory management, because I think in Java, we hear the same thing. You don't have to worry about memory management in Java. Well, you have to know what you're doing under the hood, because otherwise you're going to end up with bugs and problems. But in principle, you don't have to individually take care of the memory management. Weak references are supported, and the memory sharing model, it's different from what you've done before. Different threads can have disjoint object graphs, and an object subgraph can be transferred between threads, but it cannot be owned by several threads at the same time. An immutable object can be shared, and there is a concept called frozen object that essentially is the Superman or the Superwoman of the immutability. It makes an object and all the references and all the everything contained by that object immutable, and that's the only way to actually share it between threads. Now, the interoperability. We can talk with Kotlin Native with C, ObjectiveC, and Swift. Kotlin can call C and ObjectiveC classes and code, and vice versa, the other way around. Kotlin can extend through extension functions ObjectiveC classes, and the other way around as well. And the memory management knows the ObjectiveC runtime. It's aware of what ObjectiveC is doing and how ObjectiveC is managing the memory. Some mapping that I think it can be interesting to understand what really is happening. When you are talking with, from Kotlin with another language, this is what is happening. Numbers are as they are. They don't get transformed. You have an integer, remains an integer. You have a float, remains a float. Strings are converted into the strings that call it from C or ObjectiveC. The collections and classes are grabbed into grabbing classes. Something interesting, I think, is that the ObjectiveC OO concepts, such as, well, we have classes, protocols, and blocks, in Kotlin are represented in matching entities. So in Kotlin, a class is obviously a class. A protocol would be an interface when it goes into Kotlin Native, and a block would go in a Lambda. And yeah, maybe another interesting point is that Kotlin also, JetBrains offers us the option of creating a Kotlin library. A Kotlin library is the same as a Java library, unsurprisingly. It holds a collection of code and functionality that can be reused and shared. Inside there is, on a Kali file, this extension is essentially a zip file, like a jar file, which contains the metadata. That means the Kotlin version that was used to create the file, information of the amount of files or classes inside, etc., and all the bytecode. And there is also some tooling for creating and storing libraries in repositories. You can imagine it's very interesting when you have your own library, you would like to have some sort of Maven repository or upload it into a Nexus repository so you can access it from different apps. There are some tools from JetBrains to actually perform that. Now, we talked before about the ecosystem. No language or no technology will ever be successful if there is no support behind it. JetBrains have been working on a few things to make our life easier. There is a client-server networking library called Ktor. The coroutines are now implemented in native, although they are only single thread, so it's still this thing that's not 100% convincing. Atomic Foo, it's an atomic helper. The native version is in progress, and the Kotlin X IO. It's an IO library that is now multi-platform. And of course, there are community projects. I think there are a few folks from Square here. Yeah? So SQL Delight is now, I don't know if it's fully written already or 100%? Almost. OK. So it's, if you haven't tried, you can try it. It's a model facilitation library for SQL. You have OKIO2 under development as well at the Square, unless something has changed in the last week. And there is a company called TouchLab from New York. They organize the DroidCon New York. They also do a lot of open source software. They've written a few articles about how to use Kotlin Native. And they have this gnarch.db library. It's an SQL light access library, which has a very Android-like structure and interface. Multi-platform settings is like the shared preferences in Android and the NS user defaults, I think, in iOS. Very straightforward, written completely native in Kotlin Native. And well, this keeps developing, so I'm sure in a few months there will be more and more libraries. Now, I showed you before this module called common that compiles into the JVM or compiles into native. How do we start doing that? We essentially play with a spec/actual system. This would be the definition or the expect classes that we will define on the common module. If you see there is a class with the prefix expect before that contains no implementation, just the definition of the function, and we have a main method. So that would be in the common module. Now, in each particular module, we will have something like this. We will have the class with an actual prefix. The actual, unsurprisingly, talks about the actual implementation. And it's applied to the function and to the class itself. This is the foo. I think it's easier if you see it in a real-world example. This would be a function called write log message. We write code or we write log differently in JavaScript or in Android, right? In Android, we will use Java and the standard output. In JavaScript, we will use the console. So see that there is the expect prefix before the function name. At the top, there is a enum. That enum gets compiled into every different platform, into every different model. And this is how it would look from Java. From Java, we would have actual function, and we will call print line to actually use the standard Java output to print it to the screen. In JavaScript, we will do something like this. Depending on the log level, we would print with the console a log, a warning, or an error. That's how we do things in different platforms. Now, a few considerations into state. I think that's something important in Kotlin Native, and is that an object belongs always to one thread. They cannot be shared. If you came from the Java world, this is different. It doesn't work that way. I think JetBrains like to do things a little bit differently. So I remember when Kotlin was released, classes by default are closed. You need to write open. Not everybody was happy. It's a different paradigm. I'm still trying to decide if this is good or not. They claim in the documentation that it's good because prevent a few problems. I don't know if it creates another ones. And well, if we want to share it between threads, we need to freeze the object. There is a function called freeze that essentially makes this object a super immutability object that can be changed and any reference can be changed. That way, we can share it among different threads. And it makes sense. It's obviously mutable. It doesn't matter wherever it is. Will not be modified, and we will not fall into any problem. And this object will be frozen until it's actually removed during its entire life expectancy. There are no threading primitives in Kotlin Native, such as synchronize or volatile. So a recommendation from JetBrains is to use atomic foo, this library for atomic transactions instead. And Kotlin Native can verify safe mutability. That's called Runtime Safety, and it's contained in a few programming languages. Now, to understand a little bit more what is frozen, I think, because that's a change of paradigm. What is frozen, what is not frozen? Well, essentially, every single code you have been writing until today, since you were born, is not frozen. And now you start using Kotlin Native, maybe you will start using frozen code. That's how it is. Now, how to get started? You need to clone this repository from here. If you Google for Kotlin Native, GitHub, first result. Then you need to update the dependencies. That takes a while. It goes to the Gradle file, see all dependencies, download them. Don't do that before jumping into a plane. Sometimes I think I will take a flight. I will work on the flight. I haven't updated my dependencies, and then I cannot work or do anything. And then you have to execute this command, which takes some time. And when everything is ready, you can start using this sort of syntax. Kotlin C, hello, or whatever file, -u output. I maybe can show you very fast how to do it, if I'm able to move this here. It's clear enough? OK, so here I'm calling, I have a file called, I can probably, if I can see on the other screen. OK, so essentially, this is a hello world, right? I have a main function with a print line, nothing very special. And I'm going to compile it. First problem here, can you find any problem? It takes a freaking amount of time to compile anything with Kotlin Native. This is a hello world. It's nothing else. And it's, you know. So I'm particularly for a client of mine doing the transaction, converting some DTO classes into Kotlin Native, because we are dreaming of, OK, we could maybe modify them only once, upload them to a different Maven repository, a pod file repository, have them automatically on iOS, on Android. And right now, we are not building them on our CI every time there is a change, but with night builds, because otherwise, we cannot build anything else in the entire day. So now we have this file. And if I call the hello world file, here, it will print the content of the file, hello, on the console. So that's how it works. Essentially like JavaC for compiling everything. What I am, yeah. OK, so well, that's Kotlin Native. It's essentially Kotlin on steroids, have a few limitations. It's being developed very fast. It changes with, well, every month, essentially, every 2 months, we have new versions. There are release candidates that you can check. JetBrains is it's a community company, so they have a Slack where they are continuously, the same engineers from JetBrains are talking with any folk over there. They release early access preview versions where you can give your opinion and make code contributions, etc. It's hard to make any prediction. But I read this sentence from a guy called Adrian Kowaczewski. He wrote an article called How to be a Developer After 40. And he said that, I don't know what will happen in 10 years, but surely there will be a person asking about a regular expression in Stack Overflow, and there will be a new JavaScript framework. Probably there will be a new multi-platform framework. I'm very sure that will happen as well. Whereas Kotlin Native will be a thing or not, it's hard to predict, but I think it has its numbers, because it's backed up by a company that is doing the right things. They have a proof track of records with Kotlin and all the tooling they're doing, and it actually makes sense in the current world. Not for making the single development in one language, but to be able to serve these components that we have in all the apps. Now, Flutter versus Kotlin Native. Who have used Flutter before? Hey, that's more popular. Well, I'm not by no means an expert in Flutter. In my experience, Flutter is very oriented towards the UI. You have the custom widgets that they're drawing in their own canvas, and apparently they've done a very good job at doing it. If UI is a thing in your company / scenario / life, it's something maybe you could take a look at. I think Dart has a better threading support. Now in Kotlin, Kotlin Native is a little bit limited. On the other hand, I find in general Kotlin, except the compilation part, the execution part, is more performant, and they have a better ecosystem around it. Again, there are no silver bullets in computer science. You need to take all the facts, put them together, and see what fits better for you. And it's probably not the same that would fit your neighbor or your colleague. Now, some personal recommendations backed up by, not by science, but by me. I think it's something to be used with caution. Right now, the version is still not stable. It's 0.93. Will be stable very likely in the first quarter of the next year, but as of today, it isn't. It makes sense to use it for shared components, not for UI, not for substituting the technology you were using before, but for avoiding repetitive work that can be easily centralized. Keep versioning in mind. Even if some of those big companies never go into the stable version, like Gmail in Google, it was already there for a few years and was still beta. I think it's wise to wait until there is a final and a stable version, and never compromise 100% of a project. It's good to apply it progressively, not from once and until the end, and start getting your own impressions and your own feelings about it. Further resources, Kotlin Slack. If you are into Slack, in this Slack you have all the people from JetBrains that are asking, well, you can ask them whatever you want. They actually are very cooperative and collaborative. Resources from TouchLab. In this GitHub, you have a lot of documentation about Kotlin Native and projects they've been doing, and actually focusing a lot on Kotlin Native, on how to use Kotlin Native for iOS and Android. They did a few apps already and explained their experience. A bit of a spam here. I handle the Kotlin Weekly. It's like the Android Weekly, but for Kotlin. So you get articles every Sunday. And of course, the Kotlin Native documentation. If you Google Kotlin Native documentation, first link on Google, you'll find all the things in detail. And if you want really to dive into, for example, the mapping between classes, threading, etc., you have all the technical details there, as well as step-by-step tutorials on every point. That was everything. Thanks for being here. You've been a fantastic public. And if you have any questions, I'll be more than happy to answer if I know the answer to them.
Thank you, Enrique. Is there any questions?
So question about using Kotlin and like native platforms. Did you notice any particular oddities when the compiler like transforms the code, or because like when working with Android and Kotlin, in some cases the syntax generates unexpected results?
Well, you might find some of them. I'm thinking of a post that I saw, not that recently actually, but it was somehow compiling into a Java library version that one Java component that should not be there. From time to time, yeah, you find some troubles. I think it's getting much better. If I have to talk right now of a drawback, is the compiling time. I think it's not practical. Right. The approach from JetBrains was actually to, let's gonna make it work, and then we will optimize in the future. That's for me the first, together with the fact that it's not a stable framework, I would say those are the two things that prevent from total productive adoption.
All right, well, thanks so much, Enrique,
Thank
everybody.
you very much.
If so,